classification of blood types, let's review what we know about blood. According to the textbook, about half of the volume of blood is made up of blood cells that begin as stem cells in bone marrow. And these stem cells can develop into any of the other kind of cells found in blood, including red cells, white cells, and platelets. So, some stem cells become white cells or leukocytes, and these are essential to the immune system. And when bacterial germs invade the body, some of the white cells form antibodies to resist the infection directly, while other white cells begin to work on the chemistry of the foreign substance itself to fight the infection. Now, compared with red blood cells, there are relatively few white blood cells, only about 1 for every 700 red cells, and the smallest of the blood cells are called platelets. But what they don't have inside them, they make for in numbers. Well, the most of us have 2 trillion of them, and they help the clot and repair holes in the walls of blood vessels. But we need a way to transport the blood, right? Plasma is a liquid substance in plants. Most of the chemicals, vitamins and minerals, hormones and enzymes. But most stem cells become red blood cells or erythrocytes. They are the most numerous. As I mentioned before, there are about 700 to every 1 white blood cells. So the red cells give blood the color red, and they are important for what we call blood typing. And blood typing is what I want to get going on today. Now, blood types are a classification of red blood cells according to the presence of specific substances, antigenic protein, and carbohydrates. And you can see them under the microscope on the surface of the cells. The 4 blood types are identified by letters A, B, AB, and O. Blood type A contains red blood cells with antigen A. Blood type B contains red blood cells with antigen B. The AB blood type contains both antigens, and the O blood type contains no antigens. But the individual with this type can form antibodies containing either A or B antigens. Excuse me, is that why the O blood type is considered a universal blood type? Because it can form antibodies with either A or B antigens? Right here. But in typing the blood, the antigens are really much more complex than this explanation might suggest. There are at least 300 different antigens. In fact, there are so many potential combinations that an individual blood type is almost as unique as a fingerprint. But anyway, these basic types are used to determine compatibility for blood transfusions. Before a transfusion is approved, hospitals are always perform a procedure called a cross-match, which involves taking a sample of donor's red blood cells and mixing them with a sample of the patient's plasma. You see, in almost every individual, the plasma contains antibodies that will react to the antigens that are found in our blood cells. So during a transfusion, antibodies in the patient's plasma can bind to antigens on the donor's red blood cells when the donor's blood is not similar to that of the patient. Well, many minor reactions can occur, like fever or chills, but some reactions are so severe that they lead to spontaneous destruction of the red blood cells from the donor, and that can result in shock or even death. So you can understand why blood type is so important. Cross-matching lowers the risk of a serious reaction. Okay, in cross-matching, we take red cell from one person, plasma from the other person, and we watch to the negative response. Take a look at this diagram. It's on page 112 in your textbook. Here's what you should be looking at with the reaction caused by incompatible blood. See how the cells clump together? The reason that is happening because the chemical reaction between the protein molecules in the red cells of one person and the plasma of the other. Now look at this slide. This diagram is on the next page in your text, and this shows the compatible match with no clumping. See how they evenly spaced. Well, of course, doctors prefer to use the same type as the patient, but the compromise have to be made in emergencies. Type A patient can't receive type B blood, and type B patient can't receive type A blood. But back to your question, once an O donor has blood that's compatible with both A and B antigens, it's the ideal, or as you said, the universal donor. In an emergency, type of blood can be used for patients of all blood types, and fortunately, worldwide, type O is the most common, followed by type A. Relatively few people have type B blood, and the fewest have type AB. Professor Stevens? Yeah. Well, actually, scientists developed artificial blood that's been used successfully in blood transfusion with human patients. It's a white fluid chemical similar to Teflon, the material that coats cookware and prevents material from adhering to it. The fluid can be used as much with all blood types, and so the cross-matching step in transfusion that can be eliminated. So far, artificial blood has done a good job of replacing the red cells by carrying oxygen through the body and eliminating carbon dioxide, but there are no white cells present, no antibodies, no platelets. So it doesn't clot and it does remain there very long. Still, continuing research on these lines should be probably encouraged. Uh, Even with cross-matching and other precautions, transfusion with human blood involves risks.